Now let us take a look at some O-level past paper questions. The reference is given at the end of the question. In the first question, ethane and propene are both gases and have the same volume. According to Avogadro's law, equal volumes of gases contain the same number of moles and molecules. Therefore, we can easily find the mass of propene. First, we find the moles of ethane by dividing its mass by its molecular mass, which is 0.66. Both gases have the same volume, so according to Avogadro's law, the number of moles will also be the same. Therefore, we can easily find the mass of propene by using the mole formula. Here, we are given the mass of ozone and are asked for the volume. Firstly, we'll find out the number of moles for ozone by the formula, mole equals given mass per molecular mass. We got 1 mole, and we know that 1 mole of any gas equals to 24 decimeters cube. Therefore, volume of 48 gram of ozone is equals to 24 decimeters cube. In next question, we are given the atomic mass and number of moles of chlorine, and are told to find the mass. So, we'll simply just rearrange the formula, mole equals to mass per atomic mass, to find the mass of chlorine. The mass we got is 71 gram. Now keeping in mind that chlorine exists as diatomic, we'll multiply 71 by 2, and our final answer will be 142 gram. To solve another question, we know that 1 mole of any substance contains 6.02 into 10 to the power 23 atoms or molecules. According to the question, the number of atoms of carbon and sulfur is the same, so the number of moles will also be the same. Once the number of moles is known, the mass of carbon can be calculated. More content related to stoichiometry is explained. The empirical formula is not the real formula. It is the simplest ratio of atoms in a compound. It does not show the actual number of atoms, only the ratio. It is calculated using the mole ratio. In this example, the masses of hydrogen and carbon are given. First, we find the moles by dividing the given masses by their atomic masses. Then we find the mole ratio. Here, carbon has 1 mole and hydrogen has 2 moles, so the empirical formula is CH2. To find the actual molecular formula, we first find the number of units. By dividing the molecular mass of the compound, 56, by the molecular mass of the empirical formula, 14, we get 4. Now, multiplying 4 by CH2, we get the actual formula C4H8. In the next example, both carbon and hydrogen have the same number of moles, 7.7. We divide both by 7.7 to get whole numbers, which gives a 1-to-1 ratio according to the mole ratio. The empirical formula is CH. We then find the number of units of the empirical formula by dividing the molecular mass of the compound, 78, by the molecular mass of the empirical formula, 13. The number of units is 6, so the actual formula is C6H6. Now let us practice some O-level past paper questions for further clarification. In this question, we only need to find the empirical formula. First, we calculate the moles of carbon, hydrogen, and oxygen. By comparing the mole ratios, we find the empirical formula to be CH2O. Here is another example of an empirical formula. The moles are given as decimals, 3.33 and 6.7, so we divide all values by the smallest number to obtain whole numbers. The empirical formula is CH2O, and its molecular mass is 30 grams. In the next question, the molecular mass is given as a range of 55 to 65, so we multiply the empirical formula by 2 to get a molecular mass of 60. Therefore, the actual formula is C2H4O2. We do not multiply by more than 2 because the molecular mass must remain within the given range. According to the law of conservation of mass, mass is neither created nor destroyed in a chemical reaction. The total mass of reactants is always equal to the total mass of products in any chemical reaction. Atoms do not get created, nor do they disappear. They just rearrange. Let us take an everyday example of burning wood. It looks like mass is lost, but the missing mass goes into the air as gases such as carbon dioxide and smoke. Finally, in this question, let us calculate the amount of lime produced when 10 tons of limestone are heated. The sum of the masses of the products is equal to the mass of the reactant, whether measured in grams or tons. If the mass of a substance is given in moles or grams dissolved in 1 cubic decimeter of solvent, the concentration is expressed in moles per cubic decimeter or grams per cubic decimeter.